A new member in the child class can have the same name as a member in the base class to redefine it. This works for all kinds of inherited members, but to demonstrate, we'll create a new getArea method. We must then specify whether the method is intended to hide or override the inherited function. By default, the new method will hide it, but the compiler gives us a warning. To remove the warning, we use the new modifier to show that we actually intended to hide the inherited function and replace it with our own implementation. Before we can override a method, we must first add the virtual modifier to the function in the base class. This modifier simply allows the function to be overridden in a derived class. We can now use the override modifier to change the implementation of the inherited function. The difference between override and new is shown if we upcast the quadrant to a rectangle. If the method is redefined with a new modifier, then we now have access to the previously hidden function defined in rectangle. On the other hand, if the method is redefined using the override modifier, then the upcast will still call the version defined in quadrant. Basically, the new modifier redefines the method down the hierarchy, while override redefines the method both up and down in the hierarchy. If we want to stop an overridden function from further being overridden in classes that inherit from this class, we can declare it as sealed, which negates the virtual modifier. A class itself can also be declared as sealed to prevent any class from inheriting it. Note that the modifiers used here work in whichever order we place them in. There is a way to access the parent method even though it's overridden. To do this, let's create a constructor and call it from the main method. Now that we're in an instance method, we have access to the base keyword, which is a reference to the base class. Whether the method is hidden or overridden, we can still reach it using this keyword. An interesting thing to note here is that we did not call rectangle's constructor, and still its fields were constructed and set to their default values. This is because whenever we call a constructor, it will implicitly also call the base class's constructor. We can use this notation to pass along parameters from one constructor to another constructor in the base class.